All right, well, hello everybody. Thanks for joining us for Concurrency's webinar. We're going to be taking a little bit of a trekking journey today, hunting for some insights using machine learning in Microsoft Fabric. I'm Brian Hayden, and I'm a solution architect here at Concurrency. If you want, you can follow me on LinkedIn. You'll notice that I do have a little bit of an outdoor theme to most of my talks, and I also do a little bit of a blog on LinkedIn as well, trying to make analogies with the outdoors to help you understand some of the technology changes. But a little bit about me, definitely an outdoors guy. You can see I like fishing. I like being out in the outdoors, hiking around. Um, and fun little fact about me, besides being a nerd, is that I'm a twin. So who's not involved in the other one? The other half of me is not involved in technology. So let's talk about today's adventures. So we're going to go on a little scouting trip. The idea here is to really just get an idea of what kind of tools we need to put in our backpack. Oftentimes I'll go out, if I've got a hunting trip in the fall. I like going out in the spring when things are kind of open and clear, and I don't have to worry about like the stress of what I'm actually trying to accomplish. Maybe it's hiking on the Appalachian Trail. But what are the things that I need to, think about? So we're going to explore some data, some insights. We're going to blaze a couple of new trails today. And hopefully by the end of this, you'll understand what the right gear is for you to use when you go on your own adventure. So let's talk about Fabric first. Hopefully most of you are aware of what it is, but it is a end-to-end analytics platform in the Microsoft ecosystem. It is basically all of the tools that you would typically build in your Microsoft Azure data ecosystem. So Data Factory, your Synapse analytics. It now even includes SQL databases, but it also supports data science pretty natively and has capabilities around real-time intelligence. So most of this is built on, most of the data estate is built on this foundation. Think of it as like a frozen lake where all of these different tracks are going to converge and you have one single unified way to deal with all the data. So everybody has the opportunity to kind of work with it. But let's think about it like from a data science process perspective. So on the data science side, typically you have a problem statement that you're trying to work with. You want to formulate, some ideas how we're going to solve it. Then you might do some data discovery, do some pre-processing, and then you experiment a little bit with the data, fine-tune what models you want to use, maybe fine-tune models or create models. And then you need to get into like an ML ops, sort of cadence where you're going to operationalize whatever it is that you're trying to build. And then the key component is leveraging, all that information that you've created and generating insights. And so, as you can see in the Microsoft platform, we've got Power BI. That's built into the Fabric ecosystem, the data science, and your ETL processes. All that is all in a unified environment. So I like to think of Microsoft Fabric as like a Swiss Army knife. So it has, with all those different tools, if you're a hiker out in the field, that's like the one thing that you got to have: compass and a Swiss Army knife. And within the Fabric ecosystem, let's dive a little bit deeper into the AI tools and the capabilities that are there. So we have the ability to do Spark jobs. We have the ability to use the analytics components in Fabric natively. But recently they've started to integrate with the Azure Machine Learning, so Azure Foundry. And we'll get into a little bit about that in some of our use cases. But hopefully this is going to eliminate like this overhead of like building a camp every time that we got to provision something. Like, we're going to have things kind of pre-built and working for us rather than against us. Taking a little bit of a step back, Concurrency has a methodology for implementing a lot of these projects. And I thought that I would talk a little bit about how we approach designing a solution, and then we're going to get into several different use cases today. So our approach is a value-focused implementation intended to de-risk or minimize the risks of building complex ML or AI workloads in Microsoft Fabric or just natively in the Azure estate as well. We typically in step one, we'll start with a POC. And in this kind of stage, what we're really trying to do is validate that the data that we think that we need it's available, that it's available, it's accessible, that there aren't any gaps in the data that need to be identified. And then we're going to do some machine learning around that. So we're going to start to leverage some models. Typically in the POC phase, we're using out-of-the-box models to engage with the data and see, our hypothesis was that we could do some forecasting or we could do some optimization. Can we see value in that data before we actually move into building out a pilot? So in the pilot stage, we validated data, we've predicted that the model is going to have some impact on it. And now we want to actually experiment with that data with real live scenarios. So we're going to build maybe an interface for that. We're going to refine the models that we're using, maybe create our own machine learning models. And we're going to use that against a day-to-day operational use. Now, if you think about it as a pilot, meaning a very focused engagement, you might have a shop floor with 15 lines in the manufacturing line. We're just going to focus on one line, and try to prove and demonstrate that that our hypothesis is working. And that also gives us an opportunity to measure the impact of what our machine learning is doing against the other lines that aren't using that. And finally, after we validated that, yep, the model can actually predict or it can optimize things better than a human could, we're going to move that into production. So here in the scenario that I just talked about, we're going to take it from one line, we're going to go into all 15 lines, and we're going to evaluate those results over time. And if that proves to be successful, then we're going to scale that out. Most manufacturing companies might have 5, 6, or 15 different manufacturing facilities. This is a way for us to look at how we're going to scale that. And maybe your Mexico facility is using a different ERP system. So that's where we talk about kind of the scaling aspect of it. Maybe you're using Dynamics in the US and you're using SAP in Mexico. While the data that we're going to analyze and leverage for these types of scenarios are going to be the same, we do have to, make a scalable, adaptable ecosystem to be able to support that. And the nice part about Microsoft Fabric is by being able to reuse things like data pipelines, we're going to have that ability to scale that out pretty effectively and efficiently. So how does Fabric support an end-to-end, kind of scenario? So there's one platform with all these different capabilities centered around Microsoft's OneLake, and from there we can connect to things like our data engineering can connect to that OneLake and push data in from our ERP, whether it's on-prem or another cloud service. We can pull data from IoT sensors in real time. And then our data science workloads like Spark jobs can connect to that OneLake to pull data out and do the analytics on it. And then serve all the information that comes out of that ML product through a Power BI dashboard. So the way that this fits together is by using pipelines in a variety of different scenarios. And the advantage of the pipelines is that these give you a start to finish, trip, that is monitored and maintained in a DevOps supported type of lifecycle. So when you make changes, you can promote those through different workspaces, through different environments, and make sure that you have consistency in tests that will control what gets pushed into your production workloads. So and you could see that using an ML ops, which is sort of like a DevOps for ML framework, we're evaluating the model before we promote it into our environment. We're validating our Python and Spark jobs before we promote that into an environment. And then we can also maintain most of the infrastructure through things like Terraform as well, and have a really robust end-to-end solution developed. So just give you a quick little snapshot of what a basic ML workflow looks like in Fabric. So most of these scenarios that we're going to talk about are going to go through the same kind of workflow. We're going to store some data. We're going to get it from whatever those data sources are. We're going to explore and analyze that data. We're probably going to make things like data corrections, like we want to change spaces to underscores. We want to convert all the currency to a single currency, things along those nature. But we're also going to kind of expose some of these insights at this point so we can start to look at that data through dashboards. And we're going to do our experimentation and our analysis through some of these temporary dashboards that are going to just help us explore the data. Once we've done that, we're going to develop and train and create jobs and pipelines to support that. We'll evaluate and score the data that we have generated through our ML process. And then we're going to finally apply the best model, and we're going to promote those models into our environment. So before we get started into some of the scenarios, because it's coming up pretty quick, I wanted to talk about some of the recent innovations. So like what are the latest and greatest kind of cool things that are coming down the pipeline? And I'll evaluate this, I'll revisit this a little bit towards the end as well. But we have this real-time data hub, which is fantastic for bringing in IoT data, and there's new capabilities that are coming out almost on a daily or weekly basis. In conjunction with that, there's a low-code data activator that allows you to set up real-time alerts and send out things like emails or Teams messages when something happens. And we're going to leverage that through a variety of these different experiences today. Another recent announcement, and this is like maybe a week old, is that the Copilot features that are part of Microsoft Fabric are now going to be generally available to all Fabric SKUs. And I mean, that's a huge decision at Microsoft, and I want to applaud them for that. Previously, you needed to have an F64 SKU in order to enable Copilot within your Fabric environment. And for many organizations, that's too big of a bite to, it's an $8,000 a month Fabric SKU. So it was just a bit much for people to chew off for that feature. But now you can try it out with a smaller F4, F6 SKU that's only going to cost you a couple $100 a month, and get those benefits. And the Copilot features aren't just about exploring your data, like things like show me how many unique customers I have or things like that, but it can also explore scenarios that are a little bit more complex as long as it can understand the data. And then you also get those benefits as part of your machine learning Python scripts and things like that. I'm an old .NET developer. Python's not it's like maybe my third or fourth language in terms of familiarity. So I leverage it quite a bit to help me, get some of these scenarios built out. New features coming out in notebooks. Those are getting faster and having more capabilities. And then I already kind of mentioned it, but there's a new preview feature out with the Azure AI Foundry integration. And, we're starting to find, we've always found use cases where, we have to connect to ML models in Fabric, but this makes it a really seamless integration and makes it much quicker and faster for development. And then you can expose, one of the big benefits is being able to expose some of these scenarios in agents. Expose them as agents through like Copilot chats or things of that nature. So let's get started on the journey. So theme here is that we're going to be going on an expedition, sometime later this year, and we need to get the right gear in place. We need to understand what gear is used for different scenarios, different hunting trips or different hiking trips that we want to go into. So we're going to dive into some of these real life scenarios. All right, first one, predictive maintenance. This one comes up quite a bit. Um, in like this adventure spirit, when we're going out, we got to make sure that the gear works, right? So maintaining the gear, your hiking gear is like critical if you're going to be out on a 2 or 3 week expedition. You don't want things to kind of like break down mid-journey. And so for manufacturers, it's kind of the same thing. You want to keep these machines running. I've had a couple of different scenarios that I've worked with customers on where like inkjets are going to start to fail. They get gunk built up into them. And so what can we do to like predict when the maintenance is required and be able to service those before it brings an entire operation down or an entire line down? So instead of reacting to it, like something happens, I can actually schedule the maintenance ahead of time, knowing that things are going to need to be cleaned, or that maybe like some of the conveyor belts are starting to get worn out, and we've got some vibration things that are that are happening. So the key benefits here that we're going to reduce some of the unplanned downtime, and by having better maintenance, just like sharpening or cleaning your gun or something like that, you're going to prolong the life of those assets, over time. And with regular maintenance, you typically see things like lower maintenance costs, as well. So what does this look like in Fabric? So in Fabric, what we're going to do is we're going to load the data. And that data is typically in these scenarios around predictive maintenance. They're real-time data. So we're ingesting it, into the Delta Lake where we can start to operate on it. We're going to prepare that data using something like Spark Data Frame, and we'll land that into our Lakehouse's Delta tables. And occasionally we'll use things like pandas data frames to make plotting library, make use of the plotting libraries that we're going to use. And then we perform some exploratory analysis. And like I mentioned before, what we're going to do is create some visualizations that help us understand what some of the parameters are. Like over time, we know when things have failed in the past, so we can look at those metrics and see how they correlate well with the end result. And then we're going to train and evaluate models, and using things like data science notebooks. And then once we have 15, 10, 5 models, kind of get it down to the ones that work, we'll select those ones that predict the right outputs that we're looking for, and then we can create things like dashboards and alerts. And these typically look something like this. So this use case was looking at some manufacturing components, and looking at like the torque ratios and heat across that. And you can see in the upper quadrant that those are the areas where things are starting to get a little bit dicey. And then using the data activator, what we're able to do in real time is set up alerts. And so you see when I hit that red on the graph on the right side, I kind of hit this threshold, and now I can send an alert to my manufacturing operations department through a Teams chat, through an email, or some other mechanism, and alert them that something is about to fail and they need to go and do some maintenance on the machine. So it's kind of like, hey, like I was, getting ready to go out for the day, and I looked at my compound bow, and hey, that bowstring doesn't look quite right. I probably need to go get that fixed. So things along those nature will help you keep things running in tip-top shape and save you some money. Another really common scenario that we've talked to a lot of customers about is this idea around computer vision. I use an analogy around the inkjets before, and customer that I was working was doing some printing. And so what we did is hooked up a bunch of cameras that could take pictures of the print quality and look for anomalies. And so that's a computer vision scenario where we need to train a vision model and leverage it in order to detect things that are outside of some threshold that we set. So quality inspectors, they rely on people looking at things typically. And in some scenarios, maybe the parts are coming through too fast, or people have to take breaks, and they also kind of get a little worn out, throughout the day. So using computer vision can really automate most of those inspections. I've seen some really complex scenarios that have been implemented where they're looking for really fine kind of cracks or other defects. But in the computer vision world, detecting scratches on some parts, misaligned labels, faulty solder joints, those are all kind of scenarios that are fairly easy for the computer models to be able to pick up. And so what does something like this look like? So we're going to set up some data storage, and Fabric, you have the ability to bring pictures and images, into the solution. So we're going to land that data storage in our OneLake as well, like what we've already talked about. And then we're going to prepare, our Fabric environment, building out our Spark notebooks. So for example, we could use some pre-trained ResNet models or some PyTorch libraries that are going to be built into a Fabric notebook. And these can kind of start to classify product images as okay or defective, and do that within like a browser-based environment as well. And Fabric has a lot of these libraries that are like built into the ecosystem. So there's no setup friction. You don't have to build a pipeline to bring in these SDKs or libraries. It's like having a trained sniffer dog just ready to go for you. And if you're using Azure Machine Learning, you can integrate into custom models that you might have built using custom vision, where you've pre-trained libraries, for specific use cases as well. And then as an output, something like this would look like, here's some computer chips that we were looking at, and some solder connections were not quite right. It was causing some issues with the hardware. So once the computer vision model's in place, you can flow that right through a Power BI report in Fabric, and look at like where over time how frequently you're seeing some of those issues. Going back to like that printing aspect, inkjets are notoriously unreliable, and so you're going to get some artifacts from time to time. But at the end of the day, like the scenario that we were evaluating was they were labels, delivery labels. So is it good enough to deliver, through UPS or through FedEx? That's all we really cared about, was it was good enough for somebody to be able to read it. But we did track, the defects over time, so that when those defects started to happen on a more frequent basis, we knew that it was time for us to do some cleaning on the inkjet printers and get things ready for the next run. Another real common scenario is some forecast scenarios. I've got a couple of these. There's demand forecasting, typically like in a sales, using some of the sales data. The analogy here is kind of thinking about the weather. Like I'm about to go fishing on Lake Michigan. The first thing that I do is check the weather, check what the wave forecast is. Is it going to be safe for me to go? Or more importantly, like, is there a window of time that I need to be back and I need to be aware of? So this is kind of the same thing with manufacturers. They've got to do demand forecasting so they can predict when their product demand is going to be at the highest point and at the lowest point. This will eventually flow into things like supply chain management. But at the end of the day, we want to make sure that we have the right products at the right time for the orders that are going to be coming in. And so how do we actually accomplish this? Well, taking a step back, remember I talked about our pilot and our POC phase. So we would start off with a risk minimized approach. This in our vernacular was step one of our approach. And we're going to do a data audit, and we're going to do a quality check of the data, and we'll do a simple feasibility assessment as part of that kickoff of that data discovery to make sure that we have a path forward to build a proof of concept to actually use the data in a model. So we'll pilot some AI models with something like AI Foundry. We'll do some quick validations, and then we're going to spend a little bit of time making some adjustments to either the data that we're feeding into it, or maybe we're going to swap out some different models and look at which ones are performing best. But the outcome of this is that we've got some evidence-based, we've got evidence in terms of actual numbers that we were able to predict what the sales forecast was going to look like, and maybe use it to drive some of our decisions. So using those two, using those two first steps, like, okay, what are we going to get to? We're going to centralize our data in one lake. In a lot of these scenarios, we're pulling data from a variety of different sources. You might have your CRM, you might have an ERP, and for sales history, market indicators, if you're doing weather, you're looking at the weather forecast. But you get all those data from ERP systems and CSV files, and maybe even some IoT signals from your smart products, and you consolidate that into your one lake. This gives you a comprehensive view of all your data. So it's like having like the full weather map rather than just like the local forecast. My trip is going to be spanning a couple 100 miles, and I need to have a holistic picture about it. So once we've got that data, we can use something like Fabric Spark to work through large historical data sets, and we can process that to find patterns and outliers, things that we might want to ignore. Data scientists can train time series forecasting models using a variety of different models like Profit, or even just do this right inside of a Fabric notebook, leveraging some of the out-of-the-box Python libraries. Once that's done, we're going to automate the forecasting pipelines that are built into Microsoft Fabric, and then visualize some of those forecasts in Power BI. The key benefit here is that we've got a unified data set that can be used for a variety of different, not just the ML workflow, but it can also be used to driven sales reports for your executives. And then in the Fabric ecosystem, we have this concept of multiple workspaces, so we can do rapid iteration and deployment. Everybody's working off the single source of truth in terms of the data. And we have the ability to make a robust deployment of our workloads by using the pipelines and ML ops to manage our infrastructure and manage the code that we're deploying. The next scenario I want to look at is, so this is what something like this would look like. If you kind of zoom your head into like the little red triangle there, it's probably a little bit hard to see, but we've got an actual value of what our sales forecasting was. And then we had like a forecasted value, and that's that darker blue line that's on the right side of the graph. And right about here, you can see a divergence where we were forecasting sales to go up, and in real time we were seeing that the actual values were going down. And so using the data activator, we're able to set up alerts that somebody might want to take a look at something so they can adjust maybe their supply chain or flag certain conditions for a variety of different reasons. So what this can do is help you forecast things like a stock out of critical item for next month. You see if your predicted value is lower than your actual value of consumption, you're probably going to run out of stock, and we can automate some of those alerts for you as well, rather than just having a human being using spreadsheets and making a decision there. Supply chain optimization, this is also a pretty complex problem, but it's very similar to the to the sales forecasting in terms of how we would approach this problem and what our implementation is. So we do want to make sure that when we're manufacturing things that we have the right parts at the right time, and that we're not overcompensating for delivery issues that may occur with for a variety of different reasons. One of the customers that we worked with had 5 or 6 different vendors that they would use for a specific raw material, and when they would forecast, they try to figure out, well, this part coming from Mexico or this material coming from Mexico, we're able to get it quicker, but it costs quite a bit more than the stuff that we're getting from China. So, but the China deliveries are really kind of unreliable, in comparison. So they would use, short-term resupplies, at a higher cost and do some of their long-term forecasting. And by doing it that way, they were able to reduce their warehouse capacity by 60%. Something in that. I mean, it was ridiculous. It was millions and millions of dollars of raw materials that they didn't have to have on stock, and so they were able to just get what they needed when they needed it in order to complete the manufacturing process. So you're minimizing your carrying cost of your inventory, and also, as importantly, using these forecast models as some of your key inputs change, you can make quicker decisions and minimize the amount of cost for how you're spending your money in those scenarios as well. So very similar implementation pattern to the sales forecast. We're going to bring data in from a variety of different systems. Right now, I'm working on one that is pulling data from ERP systems, as well as transportation and logistics, and even real time on the delivery trucks, using like IoT sensors that are embedded in the trucks to be able to tell where they are, in real time. And then we can build dashboards, based off of that. But so we're consolidating the data. We do some data cleanup, do some exploratory data analysis, automate our pipelines for continuous optimization. And here's a little bit different than some of the supply chain stuff or the sales forecasting, because supply chain is really volatile based on things like Panama Canal or COVID, when that happened. And so in these scenarios, we typically create automation around optimizing the models that we use so they can retrain themselves, month to month or week to week, and perform updates to those models based on what the current market conditions are. Again, a nice takeaway for this: when you implement one of these strategies, you have a unified data set, data visibility across the organization. Much of this data can be used to calculate the cost of manufacture per SKU, or what customers are costing us the least because their order frequency and whatever else. So a lot of insights that you can make. But most importantly, this helps with automating some of the decision making that happens, especially in the supply chain, where you have to make quick decisions when you get a large order and you need to fulfill it. So typical dashboard might look like this, that trend lines or the forecast scenarios are emphasized, and then we can see where the actuals are running. So we would use this to optimize inventories levels. What is our predicted, sales looking like, and how are we trending against the lines that we had forecasted? And then you could actually connect a lot of these pipelines to your ERP system. So that can feed into a recommended production schedule, which is another scenario that I'm working with another customer on. Is I've got all this work that has to get done over the next 2 or 3 days. How do I optimize my shop floor to work with that, and make sure that I have everybody working and I'm not paying excessive overtime? So a lot of different use cases when we think about optimization, a little bit different than sales forecasting. because what we're trying to do is make real-time decisions in the optimization scenarios, and not just trying to forecast for cash flow. Another common scenario that we run into with manufacturing companies is energy usage. It's a big component of the manufacturing. And then there's also just how do we reduce our impact on the environment, as part of that as well. So just like when I go on a long trip, I've got to be really conscientious about how I manage things like power, on my phone or on my watch or my electronic GPS. I have to manage that power consumption pretty carefully. Otherwise, I'm going to be carrying around a large 12-volt marine battery, and my back's going to hurt because I'm carrying that in a backpack. But most manufacturing companies are looking for ways to have less impact on the environment, and also just reduce the energy consumption, which is a direct component of cost. And in a lot of cases, it's the highest cost that they have is their energy consumption. So we don't want to drain those resources. We want to have some of those cost savings, and then we can put a green stamp on our website, so that people know that we're doing the right things for the environment. So here, a couple of different steps from how we would, normally calculate optimization. We're definitely going to do the energy data, bring all that into our One Lake, and do our exploratory analysis. But we might want to look at other areas that, like what are the forecasted energy pricing going to look like, and then on top of that, we're going to use that data to manage our HVAC systems in real time so that we can reduce some of our electricity usage. And a lot of companies are using IoT sensor data for something like that, from meters or their equipment, that are on site, or even to predict gas consumption for trucks that are out doing deliveries. So this showcases the ability to use both streaming data, in real time, but also, a little bit more forecast data as well. And I think kind of an important, one of the important things that we can do with this is that we can feed a lot of this data into our sustainability dashboards or our compliance reports, that we might have to serve up as, part of the regulatory environment. So this is a use case that provides a lot of cost benefits for customers, and also clear, actionable dashboards, and simplify some of the reporting requirements for your regulatory reporting. And the last scenario I wanted to talk about today was root cause analysis. So out in the wild, things never work out the way I expect them to. Sometimes I get to a campsite that I was planning on using and somebody's there. Sometimes I might wake up in the morning and somebody's rummaged through something. I shouldn't say somebody. Something has, started rummaging around some of my equipment. And so we all kind of become detectives. We start looking for tracks. We look for trails. And same thing happens in manufacturing. We have a sudden drop in, product quality. Something happens on the production line, and we got to figure out what it is that happened, but we got to do it really quickly. So in this scenario, what we're doing is we're enabling analysts to be able to look for these tracks or these little crumbs of activity that may have caused something. And those are, very much needle in the haystack kind of scenarios, and they're time consuming. And so we want to get the information to people as quick as possible. So Microsoft Fabric, it's kind of like this vast landscape where you can search for the tracks. Analysts can start to use things like Fabric's SQL or KSQL interfaces to quickly query logs. And we found that in this scenario, the Copilot features in Fabric are exceptionally useful, because you can do things like what's different about the batches where the defect rate was high. And so like a human is going to say, well, I want to look at these different factors and, look at over time what was different. And we don't have to do that if we're leveraging something like Copilot and it understands the data. It can just go out and give you a report and let you know that these are some of the anomalies that we ran into. And so in real time, especially in these real-time scenarios where something's happening and that production line being down could cost tens or hundreds of thousands of dollars. It's important for us to be able to make decisions quickly. And if you can set up a unified data estate that bring all this different data together, a lot of times you can make decisions much quicker. So that was the last scenario that I had. I wanted to share, some of the big news that's coming out about Microsoft Fabric. Most of this I've already talked about. On the left side of the screen, you can see all the what's new stuff. This is all the stuff that's in public preview at this point, and nobody's going to read that entire slide. But take a look at some of the features that are coming out. And if you don't want to do that, you've got a little bit of time to go, over the next month to go to Vegas. Fabric is having their community conference, the FabricCon, in Las Vegas on March 31st through the 2nd. And I think I remember looking at this online today, and there's a $400 discount as of right now if you were to go and register for that. But I would take a look if you're using Azure AI Foundry. This is a game changer. I mean, being able to connect not only from Fabric to your Azure AI Foundry, but from Azure's AI Foundry to Fabric as well. I mean, this is a game changer. We can connect the pipelines. We can take data, expose it to the Azure AI Foundry and vice versa. It's amazing. And then most of the companies that I'm working with haven't gotten to that F64 SKU, to start off with as they start to experiment with Fabric. So they've been really limited to understand, like, is it worth it for us to spend that extra $1,000 or $2,000 to go from an F32 to an F64? Now you can make that evaluation, without having to make that big investment. And so Copilot for everybody. And we'll see how some of the smaller organizations that are using Fabric today can benefit from those features. So just key takeaways for me, Microsoft Fabric, two big use cases that resonate with manufacturers are being able to bring all this data together from a bunch of different sources. There's new connectors that are being published almost, on a weekly basis to make getting access to your data easier. And then for manufacturers, the ability to support not just batch data, doing a nightly dump from my ERP, but also being able to bring in real-time data through IoT sensors or a variety of different mechanisms is where they really see a lot of that benefit in these kind of use cases. So next steps, if you enjoyed what I had to talk about today, I would love to have a conversation with you and your organization about any potential use cases that you might have. So please respond to the survey link that was dropped in the chat and let us know if you would like to help us scout your ML trail and pick a real world example that might be easy for us to evaluate and do that in days and not months. We can also do a data readiness assessment and build out kind of a roadmap for you. I love doing these types of engagements, maybe over the course of a week or 3 weeks or 4 weeks. We can really take a look at where your data is coming from and provide some recommendations of how we would design or architect something like that. And if you've done those things already and you're ready to kind of take the step, but you're not really familiar with Fabric, or you're not sure exactly how to get started, we put together a 6 to 8 week Fabric adoption where we'll help you get the gear, all built out, sort of give you the backpack that's already built out. but give you an end-to-end solution that takes advantage of a variety of different components in Fabric. So bringing in things like data security and purview to be able to tag and govern your data is a really big. It's a key component and a big feature of Microsoft Fabric as well. So if you need a jumpstart, that's another way that we'd love to help. So that being said, thank you very much, and please follow us on LinkedIn if you haven't already. Thanks for the feedback, and